Okay, bridge students, today we have a fun lesson on angle-angle similarity with what's called the famous flag problem, or at least I call it that. We'll learn about that in a minute. My objective is that you can recognize similar triangles. I'll use that word again, similar triangles, and use the fact that similar triangles are proportional to solve for a missing side. Okay, as you'll see, similar means in familiar language, it means basically same shape, triangles or other polygons that are the same shape. But in a more technical kind of math sense, it means that we have angles that are congruent. I'm going to highlight that here. The angles in similar triangles are congruent. And the sides, this is the key for the most interesting part of our work today, I think. The sides are proportional. All right. So here's the question. Why are these two triangles here similar? I'll let you think about that for a sec. I want you to look at them. Do they have congruent angles? Do they have proportional sides? Well, let's look at the angles here. To begin with, we notice that we have two 90-degree angles, one here and one here. Also, we have a 30-degree angle here, and here we have a 60-degree angle. We also know that the interior angles of both of these triangles are going to add to 180. So let's see, 180 minus 90 is 90, minus 60 is 30, so this one has to be 30. And this one, by the same logic, is going to have to be 60. Okay, so we can see that the angles here are congruent and with the two triangles. And I'm not going to go out and take a ruler and measure the sides, but if you were to measure the sides, and if these were in fact fully similar, you would find that the sides are in fact proportional. So let's kind of take a look here, and this gets us to what's something called the angle-angle similarity postulate, which says this: if two angles of one triangle are congruent to two angles of another triangle, then, as you just saw in the example we looked at, all the angles are going to be congruent, and the angles are similar. Oops. In fact, the triangles are similar, I should say. Okay, which brings us to the famous flag problem, and I'm kind of happy with my art here on my Apple Pencil. I hope you're happy with it too. So what we're going to do here is we're going to figure out how tall the flagpole is. And we don't know. It says here that it's X feet tall. And we should know already that we're going to be working with angle-angle similarity, because I just taught you that. And so we have to sort of see, okay, what are the two triangles here that that could be similar? They could be the same shape, but not necessarily the same size. And then I need to find the two angles that are congruent in order to prove that the triangles are congruent. And so let's look here. There's really only two triangles here, so I'm going to write them down. I'm going to do it in this kind of magenta color here. So we have triangle, the big triangle, A, B, C. And we have the smaller triangle, oops, let's see if we can do that, yeah, DEC. By the way, we have this flagpole and we have the sun obviously here. Here's a little sign down here, and we know that that's 4 feet tall, and the sun is casting a shadow. The flagpole casts a shadow, and the sign casts a shadow. In any case, let's go back to the angles. I'm hoping that maybe you see that we have 2 right angles here. Draw those in red. Here's one right angle. Here's another right angle right here. Yeah. And then what's the other angle that is similar in both the large triangle formed by the flag and the small triangle formed by the sign? And some of you may see that it's right here. Both those triangles share. Sometimes we can fill in the angles. Right there. Angle C. Okay. So we know then that triangle ABC is similar, and we use a little squiggly line to show similar to triangle DEC. The large right triangle is similar to the small right triangle, which means, and this is the key here, again, the sides are proportional. The sides are proportional, which means we get to have fun with our proportions. Once again, I've said to you guys when I had you in class before that proportions are, and proportional reasoning is really at the heart of middle school math. And here's one more example. All right, so we have, in this case, we have the ratio of the, sometimes it's good to use words first. We have the height over the shadow. Is going to be, because the triangles are similar, it's equal to the ratio of the height over the shadow. Cool. So let's take a look first at the larger triangle, and the flagpole we don't know, right? It's X feet tall. We know that the shadow it casts is 30 feet. And at this point, we don't have to write in feet. We need to put feet back in our answer, though. We know that the sign is 4 feet tall, and the shadow it casts is 6 feet tall. Okay. We could reduce the fraction, but you might see right here that 6 times 5 makes 30, and so 4 times 5 is 20, and x equals 20 feet. That flagpole, see if we can bring my problem back up here, is 20 feet tall. So that's an application of proportional reasoning and also the concept of triangle similarity. Thank you for listening. Once again, we're going to have some practice problems here, and we're at the end of our little module, and so we're going to have a quiz coming up after those practice problems, but I'll talk more about that later.